Difference of squares is a method that we can use when we have two terms, but it can only work in a very specific situation. So the word says difference of squares, which means there has to be a subtraction or difference between the two terms, and both of these terms have to be squares. So difference of squares. Okay? So that means I should be able to take a square root of them. So if I take a square root of x squared, it gives me x. And if I take a square root of 81, it will give me a 9. So the two factors you will end up getting will be x minus 9 and x plus 9. Which one you write first doesn't matter. You could write it as x plus 9 times x minus 9. Now you can check how these are the two factors by FOILing them out. Okay? So if you were to FOIL these out, you'll notice x times x gives me x squared. X times a positive 9 gives me a positive 9x. Negative 9 and x gives me a negative 9x. And a negative 9 and a positive 9 give me a negative 81. Very important, so watch the signs. The fact that you had a positive and a negative in each factor gave you this unique combination, positive 9 and a negative 9, which then cancel out. And you're left with just x squared minus 81. How did I just end up with a negative? And it will always be negative because the negative and the positive will give me a negative. That's how you get the difference of squares. If it was any other, so if you had two positives, guess what would happen? The first would be fine, but when you go ahead to do the next ones, you will get up with positive 9x and positive 9x and positive 81, which means that inside two numbers won't cancel out, they will actually become 18x plus 81. Similar thing would happen if they were both negatives. You will get x squared minus 18x plus 81 again. So you can only do this method if you have a difference and both of these are perfect squares. And that's why when we write the factors, we write one to be positive and one to be negative. Okay? When you're checking for GCF, when you're checking for difference of squares, check for GCF. Sometimes there are some examples that looks like GCF, the difference of squares cannot be done. So for example, something like this. When we look at it, it doesn't look like these are perfect squares, but if you do take a GCF out, then you can see how both of these are actually perfect squares. And you can take a square root of them. So the square root of x squared is x, so minus 2, and then x plus 2. So if you don't check for GCF, the question may look like it cannot be factorized. And that same thing is happening in part D here. We should check for our GCF first. So if I were to take a GCF out, I can take a 16 out. I'm left with x squared minus 4. And then I can again do more difference of squares on it, leaving me with t minus 2 and t plus 2. Now, some of you may say, but I could do this question without taking a GCF out. And that's right, you can. So let's see what would happen if you weren't to do any GCF and straight go into difference of squares. You will get 4t minus 8 and 4t plus 8. The problem here is that it's not fully factored. So now what you have to do is to take a GCF out of both these terms now, both these factors. So from the first factor, you have to take a 4 out. And from the second one, another 4 out. And then the 4 and 4 multiply to become 16. So you do end up with the same answer, but you end up doing more steps. So I would suggest just do the GCF right in the beginning. It will make your work a lot easier. Now please pause this video and try part B and C on your own. If you get the answers that you see on the screen on Moodle, that means you're good. You can move to the next example. Otherwise, continue this video. Now, in the second example, part B here, we're going to try doing that again. There is no GCF, so we're going to go ahead and then see if we can do the difference of squares on it. Yes, we can. The square root of 25a squared is 5a, and this is a 7. So plus 7 and then 5a minus 7. Okay. Part C, again checking, both are perfect squares, so I can go ahead and take a square root of them, but the problem is that these have a positive in them, and this cannot work in in difference of squares, so this question we would say it cannot be factorized. Okay. So if there is no difference sign or subtraction sign, we cannot factorize it.